Friends, in the board exam, the calculators are not allowed, and still we need to do some difficult mathematical operations like division, multiplication, or finding square root. Uh, though the calculators are not allowed, students are provided with the log tables, and they are required to solve such problems using the log tables. So the idea of this video is to explain you how to refer to the log tables, how to solve problems involving division, multiplication, addition, square root, and stuff like that. So I have taken a small example, a simple example to illustrate the use of a log table, and I hope that this video would help you clear all the concepts related to the use of log table in the board exam. So let us take an example which I'll show you. The example is of division where you are required to find the value of x, and the question is, in the numerator you have 2.303 and divided by 3.839 into 10 raised to minus 12. So this is the question to be solved. You are required to find the value of x. Okay, so this appears to be a bit complicated by manual operation, but by logarithmic tables we can easily solve this as will be shown in this video. For that you need to take the log on both sides. So if I take log on both sides, this becomes log of x and this becomes log of 2.303 upon 3.839 into 10 raised to minus 12. So the first step is, step one is to take a log on both the sides. The other useful information you must have is what is log of numerator upon denominator. So suppose numerator term is a and denominator term is b, that is a clear case of division. Okay, so in that case the expansion of this is log of a minus log of b. Okay, this you need to remember that if you are having two terms, one in the numerator and other in the denominator, and when you take log, then it means it is equivalent to log of the numerator minus log of the denominator. So using this concept, now your a term is this 2.303, so I have written this as log a, and the denominator is this, so this is log b. Okay, so we have now the next step as log of x is equal to log of 2.303 minus log of, in the bracket, 3.839 into 10 raised to minus 12. To move to the next step, you must again have some knowledge about the use of log, which is when there is a multiplication. So whenever there is a multiplication, as like this is a case where there is a multiplication. You are multiplying the two terms. So in terms of log, it gets to addition. Just as here in case of division, you get log of numerator, that is a, minus log of b. Similarly, when there is a multiplication, when you multiply, then in that case it is addition of the numerator and denominator. So log of a plus log of b would be log of a plus b. So log of a plus b is log of a plus log of b. So using this, now what I do is, this term I simplify, and rewrite it as log of 3.839 plus log of 10 raised to minus 12. This term was originally there, log of 2.303 minus log of this term I have rewritten. This term I have rewritten as log of 3.839 plus log of 10 raised to minus 12. Now again, this you'll find that this is expression in terms of indices, and in order to simplify it further, I need to again use this expression which involves the exponent. Okay, so whenever this some term of this form m raised to n is involved, and you take a log of this, when you take a log of this kind of term m raised to n, then it is equivalent to this n goes here and it is log to the base 10 of m. Okay, so making use of this fact, what I do is that this is m and this is n. So I can rewrite this. Okay, this is n and this is m. So I can rewrite this by bringing it over here. So this term now, which appears to be minus log to the base 10 of 10 raised to minus 12, this becomes minus 12 log 10. This becomes minus 12 log 12. Okay, because log of m raised to n is n log raised to m. So this is why you are getting this term. Okay, so this is another important expression which you must know in logarithmic operations, that log of m raised to n is n log m. Okay, now minus minus becomes plus, and then this is minus. So what you need to do is you need to get this term from the log table minus this term from the log table plus 12 times log of 10. Now from the log tables, I'll show you how, but log of 2.303 comes as 0.3623. Log of 3.3839 comes 0.5842, and log of 10 comes as 1. So this becomes in a way 0.3623 minus 0.5842 plus 12. 12 by 12 into 1 is 12. Okay, but before that, how do you get these values from the log table? So for getting these values from the log table, you need to know how the log table looks. So this is how the log table looks like, where you have certain values from 10 up to 99. Then you have certain columns from 0 to 9. And then there is an additional column row which is a mean differences thing. Now what is to be found out is, let us say that I want to find the value of 2.303 log. So for finding the log of 2.303, what I do is that I rewrite it as without decimal 2303, and then first I take the first two digits. I locate it over here, so this is 23. Then third digit I locate it over here, which is 0, and then corresponding value I get from this like this. Okay, here, so you get it as 3617. Okay, so if you see here, let me show you. So 0 0, okay, and this is 23 0, so this comes as the term 3617. Okay, 3617. Now 3617 has to be corrected for the mean differences. How? Mean differences, we have to refer to the last digit, that is we have to refer to 3. Now 3 is here in the mean differences, and if you look at the corresponding value in the same row like this, you will get 6. So what I do is that I add 6 to this and you get 3623. So this 3623 is the mantissa. It is called as mantissa of my answer, and I need to know the characteristic. Now for finding the characteristic, you know that there is one term behind the decimal. So when there is one term behind the decimal, I straight away minus 1, it becomes 0. So the answer becomes 0.3623. Mantissa I had discussed how you find out from the log table. This doesn't require a log table. You need to simply see how many terms are there before decimal. Now before decimal there is only one term, and minus 1 means 1 minus 1 is 0, and that is why you are taking this as 0.3629. Mind well that I am not taking the numerical value, I am just counting how many digits are there. So I am not using 2 here. Why I am using 1 here? 1 is the number of digits before the decimal, and minus 1 is 0. Okay, so this is how you get the value of log of 2.303. Similarly, if you want to get 3.839's log, again the characteristic part would be 0 because there is only one term to the left. Minus 1 would be 0, right? And then you need to find the mantissa by referring to the log table. So this does not require the log table, but this requires the log table. So for finding this, again you need to use the log table 3839. So 3839, if you want to see, let me just show you. 3839, if you practice it, then you would not find any difficulty. 38 means 38, right? Let me use a black pen now here. 38, 38, 39, that is the third column, 38th row and third column. You move downwards like this, and you move horizontally like this, and you get 5832. So for finding the value of 3839 from the log table, first two terms you have to see the row, third thing you have to see the column, and the fourth term you have to see again the column but in the mean differences. Fourth term is 9. You have to see the column, go straight downwards like this, okay, and you get the value as 10. So 10 is the value. So add 10 and you get the corrected mantissa 5842. So the corrected mantissa is 5842. Characteristic I told you would be 0. So this is how you get the log of 3.839. Now finally log of 10. Log of 10 will be very easy. Again let me rub this and look for what is the value of log of 10. So log of 10, if you look, see here very clearly, you will find that log of 10 is 0. So in the mantissa part, we will get 0. Log of 10, I want to find log of 10. Mantissa part would be 0 because log of 10 is 10th row. This is the row, and the column is 0th column, which gives you answer 0 0. Okay, and there are two places before the decimal. Okay, so 2 places before the decimal, minus 1 will give you the characteristic. So it is 1. So 2 minus 1, there are 2 places before the decimal, minus 1 is 1. So the answer is log of 10 is 1. So this is how you get log of 10 is 1. Now substituting these values in this term, log x is log of 2.303. Instead of that, I write it here. 3.839 log, I write it as 0.542, and log of 10 I write it as 1. 1 into 12 is 12. Okay, substituting this, you get, and if you solve this, you get log of x is 11.789. Now you don't want log of x, you actually want to find x. So for finding x, you have to take an anti-log on both sides. So we take anti-log on both sides, this anti-log gets cancelled and you get x, and you have to find the anti-log of this term. So for finding the anti-log of this term, again what you need to take is that you need to consider the only mantissa part. So mantissa part is 7781. This you have to see from the anti-log table. Anti-log table. Okay, and the characteristic part, what you need to do is that You have to simply multiply this with 10 raised to the characteristic. Okay, so first I will find mantissa. Okay, so mantissa is how much? Let us calculate first by referring to the log table 0.7781. Okay, what I need to do is that I need to look at the anti-log table and look for the value of 0.7781 in the anti-log table. Now anti-log table looks like this, and I want, and again their values are from 0 to 0.99, but I am interested in 0.77. So 0.77, again you locate, right? This is the row you get, desired row, and you want is, what you want is the uh, eighth one. Okay, eighth one. So this is eighth is the column, and you get the term 5.998. Okay, and the differences you would get is 5 point, the difference is 1, add the 2, you will get 5.999, right? So 5.999, you write the mantissa is like this, and then you need to multiply the characteristic raised to 10 raised to the characteristics, and you will get it as 5.999 into 10 raised to 11, right? So this is how you find the characteristic of the equation. Okay, now now in order to get the answer, we need to again refer to this. You see that what I had done is I have found the anti-log of 11.7781, and that 11.7781 anti-log, from the anti-log table I got the value as 5.999 into 10 raised to 11, and that gives me x. So but what is x? X is the solution of the division. Which division we were solving? So we were actually solving a complicated problem like this. X is equal to 2.303 upon 3.839 into 10 raised to minus 12, and by using the log table we got the answer as what? We got the answer as 5.999 into 10 raised to 11. Okay, 5.999 into 10 raised to 11. Now how did we get this? I'll just recap of this. So for that, first step was we took the log on both the sides, right? Then what we did was we found the individual logs. First we used the expression for division, which is log of a to a by b is log of a minus log of b. Then we found the corresponding values, log of 2.303, log of 3.3839 into 10 raised to minus 12. The multiplication, we used this relation, log of a into b is log of a plus log of b. And there was again one complicated stuff here in the form of m raised to n. So for that we converted it into n log to the base 10 m. Okay, so all these three relations, and if you know these three relations, and if you know how to refer to the log tables and the anti-log tables, that would give us the answer. Okay, so I hope that you would be in a position to solve a numerical which involves division, multiplication, and indices. Okay, only a quick recap that for that you need to know this three basic stuff. I'll just rewrite those. They are log of a by b is, you must know that it is log of a minus log of b. Second thing, you must know that log of a into b is log of a plus log of b. And third thing you should know is that log of m raised to n is n log m. Okay, so if you know this, then simply using log table and anti-log table, you will be in a position to solve division problem, multiplication problem, and the problem which involves indices. Okay, I hope that it is very clear. Thank you very much.